Here we will discuss three methods for numerical integration: the left point rule, the right point rule, and the trapezoid rule. The trapezoid rule I do in the next video, but the left and right point rule I do here. And the video is actually really short because we have done all this in the previous calculus class, where the left point rule and right point rule is really basically nothing else than the Riemann sum, left point Riemann sum or right point Riemann sum. Let me just review a little bit of the Riemann sum and then do an example. We want to integrate the function from a to b f of x dx. We have an interval a to b which we divide into subintervals x1, x2, x3 and so on. And then in each of these little intervals we take a representative point xi star. And then we write down the Riemann sum right here and take the limit as n goes to infinity, meaning the subintervals getting smaller and smaller and smaller until in the limit, if it converges, then we get the integral. Now the idea of numerical integration is just to stop at a finite n, so not take the limit n goes to infinity. And there were two prominent choices for the xi star. We could use the interval left point or the interval right point, and they're right here. So then for a finite n, the left point rule I call Ln is then the sum from I is 1 to n f of xi minus 1 delta xi. Okay, and you see the xi minus 1 is the left endpoint of these intervals. Similar for the right point rule, you take the finite sum I is 1 to n, where then f is evaluated at the right point of the interval. And you have seen this now several times. But let's have a closer look at these formulas and write down the terms which arise in the sum. So for the left point rule written here, if I write this out, I get f of x0 delta x1 plus f of x1 delta x2 and so on. And what is the last term? The last term is f of xn minus 1 delta xn. So we did not use the value f of xn. From our data set, say, the last entry would not be used in this integration. So this can't be quite right, can it? Okay, maybe the right point rule is better. So let's write down the right point rule in this case. So we get f of x1 delta x1 plus f of x2 delta x2 and so on. And the last term here will be f of xn delta xn. Okay, we are using the last point. But, not the first, right? So here the value of f x0 is not used. Okay, this is unfortunate. It seems like we are missing one point either way. And we do. But maybe it doesn't matter. Let's see an example. So here's the data example which we have shown you before. It's about the SARS outbreak in 2003 in Singapore. It lists the dates when the measurements were taken. They are 14 days apart. And then we have the death rate. R of t is a death per day in this time period of 14 days. We are interested in the total number of deaths due to SARS, which is the integral from 0 to 84 days R of t dt. Using the left point rule and the right point rule, we have delta t is equal to 14 for all these intervals. They have the same width. And then the left point rule, so now we have 6 intervals to look at, and we take the left points. So then we have delta t times the rate at t0 plus the rate at t1 and so on plus the rate at t5. Which means we are using these entries here, from here all the way to here. And this is used for the L6 rule. And then you can plug in the numbers and you get 24.2844. Okay, how about the right point rule? If we do the right point rule, we are forgetting the first entry. We start at RT1 and we go all the way to RT6. So this would be the right point rule from here to there. Plug in the numbers, you get 28.2206. And you see, these numbers don't match very well. So the result is not satisfying. We might need a better method. And guess what? The next method I introduce in the next video, the trapezoidal rule, will do a much better job.